That's not a parabola. That's not a parabola. These are not parabolas. How are you going to get laid if you think that bread can be modeled by a parabola? And there's so many other great examples. Orbits of planets, satellite dishes, parabolic sand dunes. And so I'm gonna try my best to use my limited knowledge, my limited teaching ability to explain to you parabolas. Let's start simple. Say you have a 1 by 1 square. The area of the square would be 1. Now let's say you have a 2 by 2 square. Now the area is 4 units. Now let's make it 3 units long. And now the area, as we square these numbers, so as 1 gets squared, turns into 1, as 2 gets squared, turns into 4, as 3 gets squared, it turns into 9. And that's what squaring numbers is. We're finding the area of the square when all of the sides are equal to that number. And when we graph this out, starting at 1, right here, 1, the area of 1 squared is 1. And then at 2, 2 squared is 4. And then 3 squared is 9. So 4, 5, 6, 7, 8, be right there. And when we graph enough of these out, we get a parabola. But what if you don't want to square numbers? What if you think it's dog water? Well, lucky for you, that's not the only way we can create parabolas. If instead we choose a point and a line, and then graph all the points where the distance from the line and the original point stay the same, we also get a parabola. Ouch. Take a look at this light. I'm gonna put this over this paper tube to get rid of all the excess light so we can just see the circle that appears. When it's perpendicular to the door, a circle forms. As we change the angle up and up, an oval starts to form that gets bigger and bigger as we get the angle higher. Once we reach a point, the top of the oval shoots infinitely high up, and now we're left with something that goes down, back around, and back up. Remind you of anything? The point that you come from being an ellipse and rotating up, and it shoots up infinitely high, just between it being infinitely high like this and being an ellipse, right there, that is a parabola. Another parabola. What is with all these parabolas? What is going on? I don't know. I don't know why. Hey, who drew this? So we have 3 ways of making a parabola, or maybe there's more, or maybe this is wrong. I don't trust me, assuming that this isn't wrong. If we square every number and plot the number we get a parabola. If we plot all the points that have the same distance from some line and some point, that makes a parabola. And if we shine a fucking light on the wall, it makes a parabola too. These have nothing to do with each other. And the reason that this is so surprising is because these 3 aren't just curves that happen to look like each other. These are the exact same curves. If we took this and we moved it a little bit up and we stretched it a little bit, it would look exactly like this. If we made this a little smaller and put it over here, it would overlay exactly with this. So the flashlight and this method and squaring numbers all result in the same exact shape, parabola curve. And they're special because anything coming directly from the top, heading downwards, will bounce off of the parabola and always, no matter where it comes from, as long as it's going straight down, be bounced to this dot, the focus. Doesn't matter if it's coming from here or from over here or from right here. It'll always bounce to the focus. And that's why you can't just say, this is a banana, it is a parabola, because it's not. It's a banana. This is a 3D parabola, or a paraboloid. It uses the sun, and since the sun is so far away, all the rays hitting the earth are essentially parallel to each other, and so when they hit this directly from the top, they all go up to the focus and can light something on fire. This is it. It's advertised for like smokers to like be able to light a cigarette in the middle of the day. I don't smoke. I'm 18, so I'm just gonna try to... I don't think this is gonna work. The most overcast day imaginable, and so there's no sun, and so this definitely won't work. But it's the day of the deadline for the thing that I'm doing, so Whoops. It's supposed to just catch on, it's supposed to catch it on fire, basically. But it doesn't. This is, oh here, there's a little thing. That's what it's supposed to do. I'm kind of like sweating my balls off right now because I have 4 hours to finish recording and upload this video. So what have we learned today? Parabolas, they're everywhere, they're awesome. They're not bananas, they're not bread, and they're not this woman, but they're still everywhere. Like things that you want to collect a bunch of coming down, like you want to focus a bunch of light to set something on fire, you want to collect a bunch of information. Satellite discs, those are made of parabolas because you have a bunch of information coming down and they can all redirect to one focus, and that's why the bigger satellite you have, the more information that you're probably going to collect. And that's why you have big satellite dishes, because then you get more information from up in the sky. Orbits can be parabolic, they can be circular, they can be ovular, they can be parabolic, and they can be hyperbolic. Remember when I shined that light on the wall? That light turned into a cone. And depending on where that cone intersected with the door, it would make a circle, a oval, thing that goes up into infinity, that's a hyperbola. And when it was perfectly balanced between going up into infinity and an oval, it made a parabola. And that is the same exact type of thing with the orbits of planets. If you have some object and its escape velocity exactly matches the escape velocity needed, it'll be a parabola. I think that's pretty cool, to be honest with you. What else? Look at this. This is a paper talking about parabolic sand dunes. Just like out in the wild, you know, sand dunes, they can be parabolic. They can like follow a parabolic shape. Why? I have no idea. This is so dense. I'm never going to be able to finish reading this. Take a look at this other paper. This is about parabolas forming when some particles are falling in like a two-dimensional setting and they fall over some object, could be any shape, and they just form a parabola. Why? They're everywhere. Yeah.